that's not it at all.
Oh, so it's not a bit of your ORM so fat, you know, when it sits around the house, it sits around the house.
Yeah, actually, yeah, it is.
Okay, so let me introduce you to everybody. Liam and session on ORM to Vietnam or computer science. Give a hand.
Alrighty, let's talk about the war. Okay, so title of this talk obviously is ORM, the Vietnam of computer science, still. So the reason for that is that there was an article written called The Vietnam of Computer Science, which was about ORM, ORM being an acronym for Object-relational mapping. And this parenthetic still part is there because that came out in 2006. So this whole conversation is 8 years old, and you know, nothing's really changed. We haven't gone anywhere. I'll get into it in more detail, but it sort of lists a whole heap of things that he doesn't like about object-relational mapping, meaning the set of patterns as well as the tooling around it, and all of this still, as far as I'm concerned, completely valid. So what I will do is I'll start by rehashing some of that old article. So we'll go through his points that he makes. Then I'll extend that with some thoughts of my own about basically some gripes about object-relational mapping. And then we'll bring things up a little bit, get a little bit more constructive, and talk about some sort of theoretical solutions to some of the problems. And then we'll have a look at some code and some ideas that I've had around maybe improving the situation a little bit. My goal with this presentation is really to look at some constructive criticism of some of these ideas and tooling, and maybe get out there the idea of that we should have a healthy skepticism about everything we do, which isn't to say that we need to throw ORMs out and do everything in MongoDB or whatever, but more just like understand the limitations of the tools that you use. So the people who created .NET and the people who created Entity Framework and then Hibernate, they're a lot smarter than me. They're a lot better looking than me. I have the utmost respect for them and their work, but I still think that to be healthy, we need to have that constructive criticism. If without that, we would never have got the heliocentric model of the solar system. You know, we wouldn't know about gravity. We wouldn't have put people into space because we wouldn't know it's there. So it's very important to be able to reflect on the status quo and talk about whether we're doing things in the best way possible. So this is Mr. Ted Neward. In 2006, he lobbed a hand grenade, wrote this article called The Vietnam of Computer Science. And I object to that straight away because it was about object-relational mapping. And to me, object-relational mapping and computer science have absolutely nothing in common at all. And it upset a few people because he referred to Vietnam and people felt he was being disrespectful. And Mr. Neward and I kind of share the opinion that he didn't mean it in a disrespectful way. It's just that is a big event in our kind of shared history, and so it's metaphorically useful, which he explained like so. So here he was explaining why he chose to use that metaphor, and he said that it represents a quagmire which starts well, gets more complicated as time passes, and before long entraps its users in a commitment that has no clear demarcation point, no clear win conditions, and no clear exit strategy. So that's how he feels about object-relational mapping, or at least he did 8 years ago. And when talking about this topic of object-relational mapping, he also refers to it as a bloody unresolved quagmire, and goes on at some length, in fact mentioning the word quagmire 8 times. So I think, you know, trying to make a point there. If I could summarise Mr. Neward's article, I would say that his feeling is that object-relational mapping tools, when we bring them into a new project, when it's simple, we get some early success. Things start out really well. And based on that early success, we make a commitment. And your ORM tool becomes a fundamental part of your architecture it's really baked in and there to stay. Then as time passes and we add more complexity, we find that that commitment we've made starts to work against us, and later success becomes more difficult. So now I wanted to go through his actual article and what he said. We'll talk briefly about each of his specific objections. And the first one is a classic that... who's heard about this particular complaint about object-relational mapping tools, right? So the object-relational mismatch. It's talked about a lot, and I just want to make sure that everybody has a reasonable understanding of exactly what we mean here. So briefly, we'll go through a couple of examples. In an object world, we may say that we have an object student alpha. We've got a couple of other objects, enrollments beta and theta. So we have 3 objects in this system, and if we want to represent that the student alpha has those 2 enrollments, the relationship looks like that. So the relationship is on the student side, it's one-to-many, and the student kind of contains its relationship to enrollments, and the direction of the dependency is from student to enrollment. This is how sort of fundamentally relations work in object systems. So if we were to take that same system and represent it relationally, we still have a student alpha, we still have enrollments beta and theta, but now we have a property of relational algebra which says that a relation can have an attribute that links to another relation, but it's exactly 1. So we can no longer have a relationship from student to enrollment that's one-to-many, because that's not allowed. So what we do is we flip the direction of the dependency around. Now the dependency is from the enrollment to the student. They're both one-to-one relationships, so we've satisfied that required property. And it's no longer the student that sort of knows about that relationship. Everything's been completely flipped around. So the fundamental job of an object-relational mapping tool, apart from obviously data access, is dealing with this translation in sort of 2 directions. And there are other areas where we run into some friction when trying to work with an object system for our software, but store our database, store our data in a relational form. And one of those that comes up for me from time to time is around trees. And trees are an amazing data structure. I hope you've all had the pleasure of working with trees. Ironically, the relational database systems that we're talking about are implemented as trees, but one of the things they're not very good at is storing data in this form. So when we're writing our code, trees are great, they're wonderful to work with. If we were doing some F#, we might have a tree data structure that looks like this. So here we have a declaration of a new type called tree, and we're saying that this tree is storing nodes that are of type ''t", and a tree is defined as being either a leaf node, in which case we're done, or a node, and a node is recursively a left branch, a right branch, and a single piece of data of that type ''t". And that's the entire definition of a fantastic tree structure that you can do amazing stuff with. Now, if we're working in C#, trees are every bit as useful. I tried and I couldn't get a tree to fit on a slide, and even if I could, you'd look at it and it'd be heaps of code, and it's very difficult to kind of see what's going on. But the point is that trees are still entirely possible to implement and still very useful. If we're moving on to a relational model, and if we ask the question of, okay, how do we store trees in a relational database? That's problem number 1. And then problem number 2 is how do we get that to work with our object-relational mapping tools? So the obvious way to do it is to have like a node table without a foreign key to itself. So we could say that each node stores a reference to its parent, which is fine. You can store a tree that way. But then if we want to query our tree, we have to write select star from node, join to nodes. So that gives you 2 levels of the tree. If you want 3 levels, you would have to join to node table again, and so on and so on and so on. If your database is really clever and has common table expressions, then you can specify that this query should be recursive, in which case it will join to itself until it hits the end of the structure, which is wonderful, but that's not going to work, generally speaking, with your ORM tool. The other thing that people commonly do is a relational database pattern called nested sets. which is very specific to relational databases. And it's a nice structure for storing trees, but again, there's just no way you're going to get that to map with nhibernate or entity framework, or even rolling your own with nested sets would be a lot of work. So Mr. Neward's next objection is around the problem of identity. And personally, I feel that we sort of start somewhat behind from the very beginning with this particular one, because identity in object systems is kind of broken even before you think about data storage and ORMs. So, like, for example, if you create two objects, like so, two objects of the same type containing the same data, and we say, are these two things equal? It says, no, they're not. I mean, you can't get any more equal than that. We have multiple concepts of equality, depending on whether we choose to look at reference types or value types, whether we're using the equality operator as shown here, or the equals method, whether we're using built-in considerations of equality, or whether for some crazy reason we've decided it's a good idea to implement our own notion of what it means for two things to be equal. And if we've done that, have we gone the whole way and made sure that the hash codes are correct so we don't break heaps of fundamental assumptions of the platform with which we're working? So that's a problem that we have straight away. That's me. Another thing that you may have seen if you're used to working with ORMs is code like this. And really, what I mean by having a healthy skepticism is that when I see something like this, I want to be a little bit confronted, because I do see things like this, and it makes no sense at all. If I have a person whose ID is the default value for an integer, then suddenly I know something about it, whether or not it's been persisted. So, which sort of ties into the issue of managing identity between objects and a relational model, in that the most common way that we implement this is we let the database take care of the identity for us. You create a new entity, you save it, it gets a primary key, that becomes an ID on your object. We say by convention that that's somehow related to actual identity. So then the problem, well, there's a number of problems, but the first one is that until you've actually saved your object, it doesn't have an identity. So you end up with this kind of thing. And that, you know, same kind of reaction there again. So I think that his objections based around identity, absolutely valid, still valid 8 years later. As you do after a good rant, and I'll get around to it myself, he tried to tie it up by putting in a bit of constructive feedback at the end. If this is the problem that we're in, what can we do about it? And Ted's first idea was, first final thought, go relational. And this is the best of the ideas that he came up with. So what he means here is we throw away objects, we bring the relational model into our program, and thus we have no object relational mapping, because it's just relational data. So if you've been around for a little while and you've worked with data sets and data tables and record sets, I think that's pretty much what he's referring to. So we've been there and done that, and I think the experience wasn't so great. Go objects. The other way to remove a mapping, try flipping it around, get rid of the other side. So I think to do this, you probably need an object database or something like that, and just have it objects the whole way through. I don't know if that's a good idea. I've never tried, but it seems like there was a peak of thinking that was a good idea, which has now trailed off. So I guess the jury's still out for me personally, but it doesn't seem to be a great idea. You can do manual mapping. So this, I guess this solves the problem, right? If you do manual mapping, you can certainly have a domain model that's exactly what you want and a relational model that's exactly what you want, and you just write the code that takes care of converting between the two representations. But that's a lot of typing, and I don't want to do it. Acceptance. This one, I think, is important, because this is what I think we've done. There's a certain kind of Stockholm syndrome that kicks in. in the developer community. And this is very useful, and I can see that there's maybe an evolutionary basis to this kind of idea. So if you're in a bad situation and there's nothing you can do about it, then of course the best thing you can do is just accept and get on with your life. But the problem with that is that then you stop looking for solutions. So I think what we need to do is accept, choose the best possibility that's available to you at the time. But if a thing is broken in some way, acknowledge that so that you can keep an eye out for a better solution. Now, his last point was integration of relational concepts. Ted stretched this out for 200 or 300 words without saying anything as far as I could tell. It just seemed like trying really hard for a compromise, and I don't know what that means. So, 2 question marks. Yeah. Okay, so that was pretty much the Vietnam of Computer Science article. It was sort of 50-50, that list of objections to ORM, and the other 50% of it was a history of the conflict in Vietnam. So, you might find that interesting reading. I thought it was pretty good. So now I'd like to move on to some of my own observations from many years of having gone through this whole process. And I want to put my hand up and say that I was an early proponent of object-relational mapping. So, it's as much my fault as anybody else's. I think the ideas started to come out sort of early 2000s, particularly the Java guys had Hibernates, and .NET, I think we were sort of a few years behind. We were stuck with the data sets, data tables thing for a while. And some of you may recall Microsoft had this thing called object spaces. Does anybody remember that? Yeah. Cool. Correct me if I'm wrong. I'm a bit fuzzy on the history, but as I recall, they published a design for a reasonably nice and well thought out object-relational mapping tool, but then didn't actually produce an implementation. Cool. So what happened was this other fellow called Paul Wilson took their spec, which I think was fairly complete, and implemented it, and he had a tool called Wilson OR Mapper. So in 2005, that's what I thought was pretty neat. I actually still have one project that uses it, which is a real pain because the repo's gone and it's dead, and that guy's probably dead too. Trying to find the documentation's a nightmare. But in a way, I'm still kind of nostalgic for that because it was a simple tool, and at the time, it felt like a big step forward. Hibernate was starting to come around the same time, so this was a port of the Java tool Hibernate. But in 2005, we had .NET 2, so .NET got generics, or as I like to call it, an actual type system. And Hibernate, they didn't have support for generics, and it just seemed like a step backwards. So I held off on Hibernate for a few more years, then swapped over to that. Then of course there was linked SQL, which was very nearly the same story as object spaces. I quite liked linked SQL. I thought it was quite well done. The problem was that it solved a very small subset of the problem. What it did really well, but it didn't do all that much. And so it got killed off ever so slightly later than object spaces, but it still felt like they never quite finished it. There were certain things that you had to open up XML files and do by hand. And it died to make way for Entity Framework, which then sucked all the oxygen out of the room, and that's pretty much what I've sort of worked with for the last 3 or 4 years. I'm guessing that a lot of people would have similar experience. So I absolutely take partial responsibility for thinking this was a good idea. So disaster queries. Ted doesn't mention this. This is a thing I see on every project, where usually what happens, right? Somebody writes a query that does some lazy loading inside a loop. Right? This is the most common thing, and that performs terribly. We profile it, and we see that we have an n+1 query. So being a conscientious developer, they replace their n+1 query with something like this. So this is proactively moving from lazy loading to eager loading. This one, I believe, is in Hibernate, but the issue in Entity Framework is exactly the same. We want to query for an invoice in this particular case, but we also know that from that invoice we're going to want to traverse to the customer and then some other information about the customer, such as their offices and contacts, which is fine. The issue is that it generates a query that looks something like that. And what we know about left outer joins as a way of joining between tables is that the result set tends to grow. In fact, I think that's probably a property of left outer joins, is that it's necessary that every time you do that, the result set can only get larger. On top of that, also, a join's a join. And here we've got 3, but it's not unusual to see 10 or 15. And databases don't like that so much. So, developer writes that query, send the query to the database. So the first problem is having to deal with the actual query with all its joins and producing this big result set. Then we have that joint result set, which has a bandwidth problem because it's 10 meg, 100 million rows. It comes back to Entity Framework in our application server. And often this is where the real problem is, because you've got this enormous result set that's been produced, and then Entity Framework kind of has to crunch and grind its way through that and crunch those 100,000 rows down to the half a dozen entities that you actually wanted. So if you're ever profiling your server and you see Entity Framework working really hard, there's a reasonable chance that there's an eager loading query that's causing this particular problem. So this costs us in multiple ways. So there's a processing time cost, there's a latency cost, and there's also a resource contention problem in that whilst your CPU is pegged at 100% processing the results of a query, it's not available to do anything else. The other option available to us is lazy loading, the intentionally leaky abstraction. So a leaky abstraction is an implemented abstraction where details and limitations of the implementation leak through. Or I like to simplify that and say that it's an abstraction where there's things that we shouldn't have to care about, but we do. And lazy loading is one of these. Ideally, we wouldn't care that if a property is lazy loaded or not, but we absolutely do care. Like, for example, you don't want to hit a lazy loaded property inside a loop, because that's going to perform very badly. Some examples of other kind of leaky abstractions to further make the point is things like TCP/IP, the networking protocol. So its abstraction is that it says, I'm a reliable protocol on top of an unreliable network. But what it actually does is it deals with packet loss by various means, which generally come back to sort of resend until you get successful acknowledgement that the transmission's happened. So it's leaky in the sense that we shouldn't have to care about the fact that network connections are not actually reliable, but we do, because if you're on a bad connection, you'll notice things suddenly going really slow with all these packets getting dropped and having to be resent and so on. Another example would be if you were to iterate over a two-dimensional array. From the perspective of a programmer, we might think, okay, we need to loop over a two-dimensional array. We can go rows then columns, or we can go columns then rows. You know, toss a coin and off you go. Is it J then I, or I then J? Doesn't matter. But because of the way the actual implementation works, it turns out that it's sort of orders of magnitude faster to go in one direction than the other. So this is that idea of we shouldn't care, but we sort of have to. And lazy loading is exactly the same. When you go to access a property on one of your entities, we have an expectation that property access is fast. But if that property is lazy loaded, when you try to access it, it's going to block, do a SQL query, and you have to wait for that result to come back. And then if you try to access that property again, it's going to be fast the second time. And I don't know if that's better or worse, because now you have this weird scenario where you sort of don't know what the cost of accessing a property is. So lazy loading, I think, has this nasty element of non-deterministic behaviour that can give you major performance problems. So that's a thing to be aware of when you're using it. But of course, the issue then is that if you don't like lazy loading, and I don't, I think that you kind of want to err in the other direction if you can. But now I've said these are the reasons why I don't like lazy loading, and 5 minutes ago was the reasons why I don't like eager loading. So, and those are the only two options you have, so you're sort of stuck either way. This is an example of the kind of query that Entity Framework encourages us to write. And this is one of those things where it's really quite clever. So we can write our queries in the same language that we use for the rest of our application, which is good. We get static type checking in the sense that if our query has an online order flag property, then our entity is going to have an online order flag property, or it won't compile. So that's quite a nice property. But then there's areas where it starts to fall apart. So this little thing here is that equality operator again, which is fine, except this is C#'s equality operator. So obviously we can't run that in our database. So there has to be something else going on here. And what's going on here, again, it's one of those abstractions. This is not, this becomes not actually code that we execute. This becomes a data structure that represents some program code, which we then give to Entity Framework to map onto a query that can actually run against a SQL database. Again, it's really clever. But the problem is that C# for a linked query expression, which is what this is not isomorphic with a SQL select statement. There's no guarantee that C# link code can map to SQL and back, vice versa. They're not two equivalent representations of the same thing. So it's good that we can write our queries in C#, and it's good that enumerable select is a method that's supported, because that was used in this example. This is how we do projections in these kind of queries. If we want to read data from a certain table format and project it to something else, so it's good that that's available. The only problem is that enumerable.select is supported, but enumerable.select is not. So it depends on which overload you use. Some of them are supported, some are not. Okay, so that's a trap to look out for. Obviously ordering is supported. This is one of the fundamental things we want to do when querying a database. Except it doesn't work when projecting to anonymous types. You can use integers in your queries, which makes sense because .NET has various integer types and SQL has integer types, so it's fairly obvious how that translation is going to work. Except you can't use unsigned integers. So this is a leaky abstraction because we write our query in a small subset of C# that's actually valid in this particular circumstance. And the compiler can't tell you if you've stuck to that valid subset. And in fact, there's no easy way to find out. A good start is to look at that MSDN page, the CLR method to canonical function mapping, and you want to make sure that every method you're using in your query has a valid mapping. You'll also have to check out the supported and unsupported link methods, which is where you'll learn that enumerable.select is both supported and unsupported. And then there's the SQL functions class. So your query has to stick to those three things. Everything you put in a query, you need to check through there and make sure it's supported. And so to me, I think that this has all become such a pain to actually get something that works that we have to start to question whether or not the abstraction outweighs its own cost. This one, I think, is fairly old kind of territory. So there's been kind of a constant back and forward over the last 10 years to try to wrestle these ORM tools to a point where we can build a domain model that is what we actually would like it to be and still get it to work, persisting data to the database. And from my perspective, I think a decade of attempting to do this, we've come back to acceptance again and just sort of given up and gone, you know what, things need to be public. I have to put virtual on that property, and so on. So, like for example, these are mostly based on entity framework, but you're required to have a no argument constructor, which doesn't seem like such a big deal. But the problem with that is that a class's constructor is the one opportunity we get to enforce invariance about that particular type, to guarantee that it's in a consistent state at any point. So as soon as you put a no argument constructor in there, you lose that capability. Adding virtual onto properties, this will be familiar to entity framework users. And it's probably just a mild annoyance. If I was more disciplined, I would remember that I always need to have virtual on there, but I don't. And the compiler's not smart enough to work out that that's required. So you get this runtime error. Pretty well every time I add a property, I get that error and have to go back and add virtual. Private properties, these are allowed under certain circumstances, but not all circumstances with entity framework. And Hibernate's better with that, and I don't entirely understand what the implementation issue is with private properties. I would have thought you could just set them via reflection, but for whatever reason, it doesn't work. So private read-only fields, which we would like to have, so that we could have the choice to have immutable data types in our application if we thought that was a valuable thing to do. So it's pretty much out of luck for entity framework. Now encapsulating collections would be a really nice thing to do. So the problem here is that if you expose a collection to some other class, the collection has methods on it in excess of what you would actually like to expose. So the adds and the removes and all of that. So what we would like to do is be able to publish the contents of the collection without publishing an ability to mutate it. And entity framework makes that very difficult. If you're a good object-oriented designer or domain-driven design type person, you would fairly commonly come across the need to have a richer set of types than the primitive types that .NET gives you. So this is things like the idea of having a money type to represent currency. Anytime that you want to extend a built-in type to be closer to what you actually need in your application, and entity framework doesn't let you do that. You can't have non-primitive types as properties on classes. But again, NHibernate's a little bit better there because it does allow that. So this is my final gripe about entity framework. One of the things that I would like to see in software is a separation between what I call computation here, which some people would call business logic or whatever. It's the kind of the meaty doing stuff part of your application where the real logic lives. Separate that from the actual data access type stuff. Entity framework doesn't make that impossible. ORMs don't make it impossible, but they do encourage you to kind of mix these two things together. Lazy loading would be one example of where you are kind of mixing them together without necessarily really knowing that you're doing that. If you've ever used the active record pattern, then that's taken that idea to the extreme and just absolutely smashing those two concerns together. So, one choice that you have, even if we do blaze ahead with object-relational mapping tools, there are still ways in which you can use them where you can at least improve on this particular metric of trying to separate the computation from the data access side of stuff. Now I'd like to get a little bit more positive. Let's talk about some solutions. I don't want to say that this is the answer to all problems, but in terms of the object-relational mismatch, document storage is a non-relational way of storing data, so the mismatch goes away. There are other problems that come along. I think that it comes down to the kind of application that you're building. Certain applications are well suited to a document style of storage, where you get nice clear boundaries between things, as opposed to relational data, which lends itself to everything being connected. Now, if your domain model is that web where everything's connected, then this is not going to work at all. I just don't think you could do it. So it's not a panacea at all, but it solves the object-relational mapping problem. It solves the eager loading, lazy loading, non-deterministic weirdness problems. But it just depends on the domain that you have. As I said before, there are a lot of advantages to eager loading over lazy loading. You at least know what's happening. So if you have the ability to eager load something in a way that's not going to cause a terrible 15-way join and a massive result set, then that's an improvement. So if we need a DSL, for querying data, look no further, frankly, than SQL. We've gone to a lot of trouble to avoid using a tool that's really perfect for what it does. So I think that some improvements can be made by moving back a little bit in that direction. So I've certainly banged my head against some entity framework queries, trying to work out how to get that link query method to produce a certain SQL statement that I know will work against the database and indexes that I have. And going through that process is utterly ridiculous, because here's an abstraction that's supposed to be helping me, and I'm just trying to work out how to get it out of the process. So I think SQL is a very, very powerful language, and I would like to see a bit of a move back in that direction. One of the problems is that we lose that type safety that you get with those link queries. But it's frankly a little bit overrated, because what it's telling you is that your query matches the type of your entity. And that's a good start, but it doesn't tell you anything about the state of your database and the schema and everything else there. So you still don't have any real type safety. If someone has removed a column from your database table, it's still going to be a runtime error. So I just don't think that that's necessarily getting us everything that we would like. So let me pose the question to you fine people. What is it that you actually want from a data access tool? So assuming for a second that we're not worried about the object-relational mapping part, and that ADO.NET is not everything that you've ever wanted, but what is it that you actually want from a data access component? What services do you need it to provide? Looking at you, Steve. Storage. You want to be able to save stuff. Yep. So I suppose you need like a way of doing that serialization part of the process. Yep. What else do you want? Storage. That's cool. You've got it all in there. You need to get it back out again. Retrieval, right? Okay. So what does that mean? Querying. What kind of queries do you want to be able to do? Okay. Well, here, I'll give you some ideas. You want to be able to do filtering. That's probably the number one thing. Filter, select by ID, select by age greater than this, and dates between this and that. So we want to be able to do filtering operations. We want to be able to do ordering, because we just do. We want to be able to do projection.
You got to be able to pull back an aggregate result set as well. Like you can't make 10 round trips to the server just because you need 10 semi-related things.
So you mean records of different type?
Yeah, or some query interface that lets you actually retrieve results without. It's the classic. So EF's got the great big join problem.
Yep.
But then you go back to the document world and you've got the problem having to do like 10 round trips to get 10 documents that are spread.
Mm-hmm. Yep. So and joins kind of comes into that in a way too, doesn't it?
Joins or whatever, something like that. Batching, or do you mean like batching?
So there's a problem in document databases where you query for a document you care about, you get an ID of that document, and then you do a query to get that next thing, and maybe get an ID from that, and so you just, because it's oriented towards one type of document at a time.
What we'd like to be able to say is, I want to know about this ID, and it goes, well, you need this
Yeah, yeah.
This one. What do they mean? Don't care.
In a relational database, joins solve that problem because you can sort of traverse as part of your query.
It's got to be web scale.
It's got to be web scale. Yeah. It's got to have a hipster approval rating of greater than 8. We want to do projection, so we want to be able to query against data of a certain type, but actually get something that's a transformation of that. That lets you do the CQRS kind of read model-y type thing. When it comes to querying, and particularly the filtering part of querying, ultimately what we need is some sort of index or something that serves that role. We need a way to do queries that aren't a big O of N linear scan through a set of data. That's pretty much a showstopper. We want to be able to do some kind of aggregate type queries, sum, min, max, average, whatever. Because if you can't do those in your database, you have a problem. There's no solution really other than to query some enormous amount of data and do that calculation in your application. It's not going to work very well. And joins, which we already kind of talked about. Now, another thing that I personally would like to have is transactions. I'm not ready to give up on transactions just yet. Maybe we have overdone it a little bit in the past, been a little bit careless with distributed transactions and such things, but at the bare minimum, I want to be able to support the old scenario where we say we're doing a transfer from one account to another, so it's a debit here, it's a credit there. Those are both within my application. I own both of those entities. I want to be able to guarantee that both of those change operations succeed together or they fail together. Because any other outcome is inconsistency and it's a bug in my application that maybe I'll catch now or maybe I won't, and it becomes a bigger problem later. So I want to be able to group together update operations and have them run in a transaction. And related to that notion is this idea of a unit of work. So it's sort of the same thing. It's a way of being able to collect up changes and then make a decision about whether I throw them all away or whether I persist them together into a database. Hopefully that's not too small for you. This is sort of pseudocode of what such a unit of work might look like at its bare minimum. We create a person called Ernesto, and he has some properties, the most interesting of which is his favourite things, which is an array. So we'll put that in there to make it sort of clear that this is non-relational data we're dealing with, it's structured data. So then I can create a unit of work, do stuff in my application. I'm going to insert my new object, Ernesto. So effectively I add to my unit of work an operation that represents an insert of some particular document. Then I make some changes to things. So I'm going to update Ernesto and set his age to 32. So now I know that in my unit of work I have to add another change operation. And this time it's an update of the same object. And when I'm happy and I've done all my inserts, updates and deletes, whatever, then I can go ahead and say commit that unit of work. Or if for whatever reason I decide not to do that, I can throw it all away. I haven't done anything, I haven't wasted any time, and I haven't put anything into an inconsistent state. Oops, I've got my arrows. Okay. And one of the things that I've found quite useful to experiment with some different ideas is Postgres. So the kind of work that I've been doing for the last decade, I've really spent a lot of time with SQL Server, and I hadn't realised that Postgres had become a really impressive database platform. Yeah, almost too impressive. It's got quite a learning curve because it can do so many different things. One of the things that it has that particularly interested me when I was thinking about all the stuff I hate about object-relational mappers is that it has a JSON column type. So you can create a relational table where the type of one of the columns is JSON, which is not so interesting of itself. SQL Server has XML, so far we're about even. No, I actually meant that. I don't care, whatever. Some way of serializing a document. But where it gets interesting is that you can query that JSON. And I don't just mean query a row and get back a chunk of text. You can query into the properties of your JSON object. So I could query my people table and I could say, get me the people where one of their favourite things is ice cream. You could do that kind of thing. And as far as I know, I couldn't work out how to do that in SQL Server with XML. And you can do projections based on the JSON documents, and most importantly, above all else, you can build indexes based on sort of any property contained in your JSON objects at any depth and whatever you want to do. And there's a couple of different index types you can choose from. It supports transactions and also joins. So I can have document storage, but also joins, and I can have multiple updates to multiple documents within the same transaction. All of which is quite nice. Okay, let us talk about chess. In the 12th century, well, no, not in the 12th century. Fairly recently, some guys discovered a chess set, which was from the 12th century, on an island to the northwest of Scotland. And the beautiful pieces and quite well preserved. They didn't get the whole set, but the point is that chess is really old. And it goes back further than that too, because I think the origins are about the 6th century or 7th century or something. So it's an old game. I'm sure we've all enjoyed a good game of chess now and then. We play chess on a 8x8 checkerboard, and traditionally the axes are marked with numbers in one direction and letters in the other direction. That didn't quite suit me, so I've gone with numbers both ways. Note the origin is bottom left. And I want to represent my game of chess thusly. So on the left I have a little bit of code. Firstly we create the pawn piece, which is this guy here. The important thing is that my piece type represents both which kind of chess piece it is, as well as its position on the board. So that that entire thing is represented by my new pawn here. Then we create the knight. So his piece type is knight, and here's row 1, column 2. And then the board is just a collection of pieces. It's everything we need to represent this state of the game here. I didn't put all the pieces on there because it sort of wasn't important to the demo I'm trying to do. Okay, so the actual code looks like that. So this bit here is sort of exactly what I had on the slide there. And then I'm just using LinkPad. That didn't go very well. Yeah, that's the problem. Oops. Sorry, I just haven't got it on my screen here. Anyway, move on. That demo is not particularly well. Oh, right. Sorry. I thought you were being smart. C# program. It was trying to read my mind. Okay, so this is purely just creating that board with the two pieces on it. So you just really this example is just to get to see the output from LinkPad. So I'm giving it the string to the dump method, and it labels that particular output here. The type is board. I've got two pieces, my pawn and my knight with their relative positions, and some GUID IDs. Okay. So now the SQL query comes back again, and this is the actual database table that I'm going to use to, oh wow, I better get cranking, to store my chess game. So it's got an ID and it's got a JSON type. Where is my database? Here. This is the really dodgy environment that comes with Postgres. So let's go ahead and create my piece table. Back to LinkPad. So now we're going to persist the state of that initial game. So it's the same thing. I'm setting up my knight and my pawn. Now we have a unit of work. We insert the pawn, we insert the knight, and then we commit the whole thing. Okay, cool. So
What's the generic type of operation GUID? Doesn't quite make sense. Or it would be piece or something like that.
operation means database operation, so it can be an insert, an update, or a delete. And GUID is the type of the identifier, because I need to know the type of the primary key. Okay. If we have a look in our database now, there you have the contents of the database, a little bit hard to read. And this is how we can query into the JSON type. So data is the column of the table, but then you can index into the various properties and sort of flick it back to relational data. Okay, so now what I want to do is implement a particular move. As you'll know from having played chess, what we just did is took the knight and killed the pawn. That's a valid move. So because the way the data is modelled is that a piece is which type of chess piece it is plus a position. If you want to represent a move, what you have to do is delete the old position and insert a new one. So what I want to show here is like how a unit of work kind of queues up all these different operations. So I've got a move method on my board, and firstly we identify which piece we want to move. So that's my knight on the bottom row, and then we have to tell it where we want to move it to. And 3-3 is where the pawn piece is. And then we have these methods which will handle the possible outcomes of that move. So there's various ways in which you can fail. So we have a success handler, which does the commit to the database, or we have an error handler, which will show us an error. So we're going to run that. Before is the previous state of the system, so that's our starting position. These are the operations that's returned from the move method. So essentially what it's doing is returning the set of changes that we need to make to the database. The first one is a delete of the pawn because he got killed. We have a delete of the knight on the first row because he's not there anymore. And then insert the knight into row 3, column 3. And then finally I sort of re-query the database to get the new state. And now we have the knight on position 3-3, like so. I'll skip this one, so I just had him move. That was not particularly interesting, it's just a delete and an insert. And then I tried to move the knight way the hell off the board to show what the error condition looks like. Which is here. So in the move method, we can either return a successful outcome or an error outcome. And one of the things we do is check the new row and new column are within the ranges of my 8x8 chessboard. And if they're not, then we return an error with an error message. So this example, again, we're taking the knight from where he is, but now I'm moving him to 999,999. It's obviously an error case. So instead of getting some operations to persist to the database, I get an error, and the new state of the world is the same as the previous state. We threw away the unit of work because it wasn't valid. Now, one nice thing about this style is testing. Because we're not intermingling the updating of a database with the calculations about moving chess pieces and whether we're landing on top of another piece or going out of range or doing anything invalid. To test, all you have to do is call the method and then do assertions based on what you get back. 5 minutes, thank you. And one consequence of that is that there becomes less need for inverting dependencies and IOC and mocks and all that stuff. Where previously I would have had to pass in repositories to my chessboard perhaps to have it save those delete and update operations, and then if I wanted to test, I'd give a mock and assert that the deletes got called and the updates got called. It's much simpler if you can sort of flatten out the whole structure, apply your logic, get back a value that represents what actually happened, and then just make assertions on that. quickly, I'll just summarise and say, please don't think that I'm saying throw out entity framework. I'll probably use it on my next project. Just beware that Stockholm syndrome. It's not the perfect tool, and just be looking for, I think, always for things that are a little bit better. And does anybody have any questions?
Do you think it'll ever be any different? I mean, do you see that?
Yeah, things always change. You know, ORM's kind of new, and things maybe had its day a little bit. I don't know.
But fundamentally, it's still always going to be an object-relational mapping issue.
Never say never, Wolfie.
I'm wondering if like some of the objections that you have, and I think most of us have, things like you've got to have the null-like constructor. If you go down to SQL, then you lose type check and that sort of stuff. I wonder whether some of that will be able, you'll be able to overcome that with Roslyn and being able to look into the compiler itself. And then you could probably have the compiler say, oh, you're trying to construct an instance of a class using null-like constructor that's a ORM managed class.
Yeah.
Or in the case of SQL, have it go and quickly parse at SQL and say, no, actually.
I think there's a lot of runtime errors that a more advanced compiler could catch for us. And I think that F# has this thing called type providers, which goes some way towards doing that. But you don't have to do it the type provider way. There's other things that a compiler could do, and maybe Roslyn will do that. I'll take any solution. It doesn't have to be whatever solves the problem. So I look forward to that day.
Might graph databases play any role in the solution?
Yeah, I mean, there's no. I've never really used one, but I presume that it's not relational, so the relational mapping part goes away. Yeah, exactly. If you're storing a graph, it solves the problem. If you're not, then, I couldn't imagine anything worse than trying to store like a complex interrelated relational style domain in a graph database. I don't think anyone suggests that that's a good idea, but they're pretty awesome.
That you said, just
Yeah.
you have that up on GitHub or something?
I'll put everything up, in the slides and all the code and stuff. I apologise that I had to rush through that a little bit. I kind of ran out of time.
Have you seen any modern day projects using something like Simple Data or Massive or anything like that out in the wild, or is it more just blog posts of people saying?
I haven't, but I haven't really looked. Those tools are interesting. I think they solve some of these problems. They don't solve some others, and they kind of reintroduce some problems that ORMs already did solve. So I'm not sure. I don't necessarily feel that they're a great step forward.
Have you used that Postgres with the JSON thing in a production environment? And performance work as well?
I have. I certainly wouldn't.
I've used Postgres before in production, but many years ago, and it was awesome.
Yeah, it's cool. I've got a site that runs on it, but I would certainly not recommend. I'm not on the internet, so that's not going to work. Certainly don't use anything that I've done here for actual software, because it's just me playing around. But I do use it on one of my sites, and it works really well. It's beautiful. So. And I find the code is really, really kind of clean and nice to work with.
Do you know if Entity Framework works with Postgres? Or is that one way it's just not?
I believe they do not.
EF7 will. EF7 is going to change it up, yeah.
Cool. All right. Thanks, everyone.